Hello guys, welcome back to our channel, Newton's Physicists. In this channel, we talk and showcase about various physics topics in order for you guys to understand and apply it in your daily lives. For today's topic, we're gonna briefly explore the law of conservation of momentum. So before we begin, kindly subscribe to our channel to show your genuine support. So, what's the law of conservation of momentum, you may ask? This law states that for a collision occurring between two objects in an isolated system, the total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. That is, the momentum lost by the first object is equal to the momentum gained by the second object, and vice versa. Also, momentum can be defined as mass in motion. All objects has mass. So if an object is moving, it will have momentum. So I know it's a lot to take in. So in order for you guys to understand it more, here's a short video presentation of real-life examples where the law of conservation of momentum is observed. The human collision. So two friends plan to meet at the mall to play bowling and billiards. However, they actually don't know what they look like and only send messages to each other. When the two friends bump into each other, they both gain and lose momentum. Thus, the concept of the law of conservation of momentum is when the total momentum of the two individuals before is equal to the total momentum after. So, here comes, boom, the law of conservation of momentum. Now, the two friends decided to play billiards first, and apparently it also shows the law of conservation of momentum. When two billiard balls collide, the collision is nearly elastic. An elastic collision is where the kinetic energy of the system is conserved before and after impact. Also, in elastic collision, momentum is always conserved. Boom! Score! Badminton. The law of conservation of momentum is observed when the person hits the shuttlecock. The momentum is transferred from the shuttlecock to the racket since the momentum of the shuttlecock is smaller than the momentum of the racket. Due to this, the shuttlecock gains momentum which is now equal to the momentum of the racket. Air-filled balloons. As you blow air into the balloon, it creates a system where the total momentum is zero. But as soon as you let go of the balloon, the air escapes with great velocity and sends the balloon in the opposite direction due to the law of conservation of momentum. You guys now have the idea or concept of the law of conservation of momentum. If you do, that's great. But if you don't, that's okay. Because we have another video to present. In this video, it sets in one of our group meetings where one of our colleagues shared a misconception about Superman saving a plane full of passengers. So here's the video clip. So yeah, hey guys. Do you have any idea or suggestions for our vlog? Our topic is about the law of conservation of momentum. Any suggestions?
I might have an idea. Let me start by showing you this video. Okay. Here is a video of Superman is trying to stop an airplane from falling. Okay. As a physics student, we know that it is not logical. Why do I say so? Okay, let us take a closer look. Superman and the airplane is moving in opposite direction. So Superman need to have the same momentum as the airplane to stop the airplane. So if we have the mass and velocity of the airplane and Superman, we can predict how much velocity is needed by Superman to stop the airplane. Let's say that the Superman is 80 kg and the airplane is 80,000 kg. The velocity of the airplane is 500 km per hour. So we can calculate that Superman need to have 500,000 km per hour of velocity to stop the airplane. With the knowledge of physics, we know that Superman cannot stop the airplane, but he will destroy the airplane as he acts as an extreme bullet with the extreme velocity. So this example is just for fun. My advice for you is don't watch movie with the point of view of physics. However, with the law of conservation of momentum, We can predict the motion in objects that are in collision, and we can design systems such as rocket engines.
Yeah, I totally get it, honestly. The whole concept is actually really nice. And the idea of like showing the misconceptions of the law of conservation momentum in movies like Superman is a great way to actually, perceive the audience that the law of conservation momentum is not supposed to be like that, apparently. So, do you guys agree with this idea? Alright. Okay, so since everybody's agreed, so let's do it. And thanks, Jonathan, for the nice idea. Thanks.
Welcome.
Interesting, right? So kids, don't believe whatever happens in movies. I'm kidding. But you should all know that things like this are understandable in the concept with movies. So don't worry too much about it. As long as you're amazed about the out of this world concepts in movies, that's totally fine. Now, we're in the last part of our video where another colleague of mine prepared a short skit that explains impulse and how it correlates with the law of conservation of momentum.
Wow, physics, can't even get it, can't understand. These things are all making me just hungry. Wow, now MCO, can't even know where to eat also. Just call my mom. Mom, I need food, mom. I'm getting hungry. Why is she not responding? Better just go find her myself. Wow, after finishing my laundry, it's time for me to relax and watch some K-drama. Ma! Faster, I want food, Ma! Woi, can you stop it? You should never interrupt a woman when she's watching an emotional scene in Descendants of the Sun. Don't you know your manners? If you're so hungry, then just cook for yourself lah. So old already. Wow, okay lah me. Next time I'm not gonna do laundry for you, I tell you. Wow, this mother is a bit too much lah. She thinks that I'm nothing without her cooking. Fine, let's see about that. But first, let me check what is in the fridge. Wow! NANI? An egg. I've never cooked an egg before leh. How hard can it be? Just cracking and frying it, right? So first things first, I'm going to need safety protective gear for this. In case any egg fragments cut my body. Then, to prevent unexpected leaks and spill, I think I'm going to use cloth to prevent unexpected leaks and spill. Okay. Let's go. Is it not cracking? Am I not strong enough for this egg?
One eternity later.
Wow, I give up already lah. This egg cannot crack one. What's wrong with this egg ah? Cannot crack also. What? Wait. Why did it crack on the table but not on the cloth? Finally relaxed after finishing one episode of K-drama. Hey, what's that boy doing ah? He's been in the kitchen for so long ah, still has not come out yet. Something must be wrong with him in the kitchen. Why is this happening? The force that I applied on the cloth was more than the table. So why did the egg crack? Of course it doesn't work lah, son. Nobody cracks an egg on a soft surface. The reason is because the average force between the cloth and the egg is much lesser than on the table. But what is happening? I tried to apply much force, but the egg is not cracking. Son, let me explain more details lah. When comparing average force applied between two surfaces, namely the table and the cloth, the table will exert more average force on the egg. Because when the egg drops and gets in contact with the table, the egg experiences less contact time on the table compared to the cloth. Thus, the quick change in velocity over a short period of time causes the force to be larger than on the cloth. Oh, so basically the cloth acts as an airbag. It increases the time of contact of the egg while reducing its speed. Oh, now I get it.
That was hilarious and amazingly appealing. I never knew that different surfaces actually affect the impulse of the object. So if you're gonna apply this concept, I suggest you guys to play pillow fight, water balloon fight, or maybe food fight with your friends and families. So we have come to the end of this video, and I hope you guys enjoyed and understood the concept of the law of conservation of momentum. So before we end this video, I would like to share my appreciation to our team that has dedicated the time and effort to making this video possible. So thank you for watching until the end. Bye!